Hello students. Well, this is the last of the videos on applications of the Pythagorean theorem. So we're going to have you do two problems. So again, I think it's best if you actually try the questions first. So pause the video, have a go, and then restart the video to check your answer. Okay, welcome back students. Now, both of these two questions that we'll be looking at in this video have one thing in common, which is there's actually no right-angled triangle shown in the diagram. So you're given a diagram, but there's no right-angled triangle. And in this particular question, it turns out there's some additional information that you don't actually need. So just because there's a number or a length given in a diagram doesn't mean you have to use it. Okay, let's have a look at the question. You're building the bookcase shown on the right. You want to put a diagonal brace across the back to support it. How long should the brace be? So again, there's no triangle given in the diagram, but if you read the question carefully, what we're interested in is putting a diagonal brace across the back. So probably the best thing we can do to start with is to draw our own diagram. So there's the back of the bookcase. Mark the lengths in. That's 2,100. The units are millimeters, fairly obviously. It's not going to be centimeters, otherwise it'd be way too long. And the other measurement that we need is 1,400 millimeters. And of course, this 800 millimeters for the depth of the bookcase is not important in this case. So sometimes you have to remove or ignore some of the information given to you. And of course, we're putting a diagonal brace across the back. Hopefully the bookcase is built with a right angle in the corner. And there we go. So I can use this triangle here. I should have written at 1400 on the other side. In fact, I'll copy it across. And now we just have to find the length of the diagonal brace. I'll call that D for diagonal brace. Okay, not too hard from this point onwards. If you've been doing the other Pythagorean questions, let's go ahead. I think I'll make that line a bit more neat. Okay, so we'll come a bit more straight down. Okay, start with the Pythagorean theorem. In fact, I should have started by labeling my diagram, so I'll do that next. So that's the hypotenuse of the right angle triangle, so that's going to be side C, that's side A, that's side B. We're trying to find the hypotenuse in this case, for which we're using the letter D. A is 1,400, B is 2,100, and I can't do those calculations in my head, so I'll bring up my trusty calculator. So I need 1,400, 1,400 squared plus 2,100 squared. And that gives me 637 and 4 zeros. And I always like to put commas in, even though it's not standard in Australia. It just makes it easier for me to see the size of the number, which is a bit over 6 million. And once again, we need to get rid of the squaring, so we take the square root of both sides. Those cross out. So that's the exact answer, but let's go ahead and get a decimal approximation. Fairly obviously, given that all of these are in millimeters, we'll answer to the nearest whole millimeter. So I've got the number just there, so I can do square root of answer, and 2523.8. That 0.8 will round it up to 2524. And the answer's in millimeters. Okay, so again, what makes this question a little bit tricky? Well, there's two things. One is there's no triangle given in the diagram. And secondly, you've got to read the question fairly carefully and ignore the fact that the bookcase has a depth of 800 millimeters. Okay, have a go with this question, please. Okay, welcome back. Now this one's not super hard. Again, there's no triangle, no right angle triangle, sorry, given in the diagram, but most students that I teach, or many of the students that I teach, realize that if that's 24 and you got right angles in both of those, I can make a triangle and that have the same length, so therefore I can put a 24 just in there. So there's the right angle triangle. I've worked out that's 24. Now what about this length right here? Well, we've got to use the fact that this entire length is 30 units. That one's 20 units, and therefore that one is 10 units. So if we wanted to, we could then just go ahead and redraw just the information we're interested in, x, 10, and 24. Okay, I don't think that's entirely necessary in this question because it's pretty obvious there's the triangle just there. Okay, once again, we're looking for the hypotenuse. That's side C, that's side A, that's side B. Start by writing the Pythagorean theorem. As we do with all of these questions, substitute in place of C. We're going to write that with the letter X. In place of A, we're going to substitute 10. In place of B, we're going to substitute 24. Okay, once again, I think I'll use my calculator for this. In fact, I'll do it slightly differently. In fact, I'm going to erase that. Here's a little shortcut that once you get really good at these, you can probably use this shortcut. I know what I have to do next, which is to evaluate that and get that down to a single number and then take the square root. So as a little shortcut, I'm going to put all of that together into one step. So now I know that what I have to do is take the square root of all of that to get x. Okay, I'll type that into my calculator. This will save me one line of setting out. So I need square root 10 squared plus 24 squared. Okay, a quick check. Yep, that matches that. And in one step, I get the exact answer, 26. So I can just write that down. And in this case, there's no units, so we stop there. Okay, that's all we're going to do on applications of the Pythagorean theorem. I'm sure your textbook has a bunch of others, so my suggestion is go and get lots and lots of practice at these from your textbook. Okay, with a few more videos to go. In the next video, we're going to look at a little interesting aspect of the Pythagorean theorem called Pythagorean triads or Pythagorean triples.